Today we're going to go over the function Trimline development. To do that, we go to Application, Metal Forming, Blind Size Trimline Development. And we need to import the initial mesh. Initial blank mesh can be the very first flat blank or some intermediate shapes, so trim operation or whatever shape. So in this case, we input the DYNA file from operation 10. So that's the initial stage. Don't have to be flat, can be, intermediate shapes. And then final formed part, import. So final stage for us is going to be operation 6. So this one, you do need to use DYNA file for the current version. You can use other format, only DYNA file. Open. And then we can see the final shape obviously went through the draw stage and flanging and the cam. So there are many stages in between. All we need is the final shape. And of course, this has to be from the same simulation run because the node and element have to match. The adaptive mesh is fine, but the main structure of the element node have to be matched to the same database. So for target part, we can bring in either the boundary curve or the meshed part, which represent the final shape. Our case, we have the boundary curve, so I'm going to bring in the boundary curve as edges or step file. So I have the edges. Bring in, make sure the unit is correct. Okay, so we can see the final shape does have quite a lot of other lines here, the piercing holes and trim. And we are going to run this job. So I'm going to select the folder. I'll use the same folder, I bring in the file. And then I'll call it, let's say, try1 subfolder. And the file name is try1. You can put extension or not putting extension is fine. K stands for keyword file. So save keyword. And then you will see lower right corner says finish writing LS-DYNA output file. Double click here, you can see more information from the message window. Close that, open folder. Open folder will bring you where you save the subfolder. So if I go into it, you will see there are only 4 files here: initial, final, target, and the main head file. So to run this, we need to select the head file. I'm going to run with ls run. You can run with other job submitter or the file manager, or anything to bring the input file to the solver. So I'm going to select the input file. I'll go to my folder, select the head file. And next thing you need to be careful is run double precision, because this is an implicit run again. So we need a double precision for implicit run. I'm going to select double precision, which is the double precision solver. Well, this is the extra thing I put in. Okay, then we can run. Select this, and this will submit the input file to the solver. You do need the LS-DYNA revision R90 or higher. You can tell the information from the initial window of this DOS window. So it says new trim curve are outputted in this file. So 5 iterations, and this is done. So let's go back to the interface, go to result, import the IBO file, import, go to the folder, pick this, open, and that's the developed curve. We can take a close look at this curve. I'm going to dismiss that. We can tell the initial estimation of the blank is pretty close to the curve developed a little bit over here, and then a little bit over here. Pretty good here, a little bit short here, and then keep going, over, short. It's very close, but this curve will be precisely help you match the final shape, and also give you the location of the trim hole. shape. And right here we have a little bit mismatch from the initial shape and final shape. There's extra tab here, and the curve does ignore the tab, follow where you have the final shape. You might get a little bit confused here. So the next question is, do I need to rerun with this new curve to make sure it match? The answer is, if it's very close, you probably don't need to rerun them. If it's very far away, you might need to, because there are compound deformation change. To rerun that, it's quite straightforward. You bring back this line. You can save this line. Right in the window, you have the save function. You can save those lines to edges or step file and just replace your blank and rerun them. Rerun the whole stages. All right, I hope you find this function very useful. I do have some customers that they need to develop the trimline on the part which has the spring back. So what you need to do is you need to have the dining file before spring back and after spring back, which you need to be the matching run to get the both shape, and then you can project the trimline from the original nominal shape to the spring back shape with this function. And there are many other usage. For the local trimline development, all you need to do is just provide the local line, just not a closed line, an open line, and then program will develop the same way. Thank you.